1 past the hour, so let's start from reviewing agenda for today. So next to the topics we covered yesterday, we will start with differences between Qt for MCUs and Qt. We will see what is exclusive for Qt for MCUs, what is different compared to big Qt, if it goes about the things available in Qt for MCUs. And then we will talk about styling the controls. So you will learn how to provide different styling, different appearance for your buttons, sliders, and possibly other controls that are coming together with Qt for MCUs. We'll have a short coffee break. And after that, we will see how to translate our application to different languages. There will be a lunch break, and then the last topic, the quite big one, but really interesting one, the C++ integration. So you can see how to create your interfaces in C++ that will then connect to your QML code directly in the QML. And this is how today's training will look like. So let's start with differences. So what is different and what is intended to be different? As I said before, the version in import is an optional thing. In Qt for MCUs is completely skipped, but it's needed if you are going to work with Qt Creator, and then Qt Creator will throw an error for you, and this is the only place where it can be needed. But in general, the Qt for MCUs framework itself does not need that thing. The object's parent property is read-only, so that means you cannot change the parent in the UI tree. So well, that's the definition of read-only, and it's constant. List model and list elements are also read-only. If you are going to and want to create mutable list models that are about to change during the runtime, you will have to use the C++ model for it, and we will do that later on this day. And there is no separate font object, so well, yeah, you don't have to separate type for it. Simply, if you are going to define the font, it's inside the text element as one of the properties. There is also no definition of what is exactly supported if it goes about JavaScript support. There is no definition of the minimal subset, but for sure you can use property bindings, signal handlers, and the custom functions. And about functions, you have to use strong typing, which is inspired by TypeScript. And here is the example of it. So you have to provide types for the arguments and for the return type. And this is caused by the conversion between QML and to C++. So we then know to which argument types and return type we should translate our function to. And well, there's no support for the external JavaScript files. So every JavaScript code that you are going to embed in your QML code has to be directly in it. And you cannot just include external whole file from the outside. And there are a few types that are exclusive to Qt for MCUs and are not available in the big Qt. And one of them is the colorized image, which provides you a way to colorize the asset that is provided as a source for it. It's available in the Qt Quick Ultralite Extras module, and in the normal Qt, its equivalent is to enable the layer on the image and then provide the effect, which is the color overlay of a given color. Well, so this is exactly how it works on Qt for MCUs. And this type is not available in the big Qt. Static text is a component which works in general in the final application UI. it does not have any difference between text. And the main difference is underneath and under the hood. So internally, this component produces pre-computed values for some of the parts of the text. So these pre-rendered glyphs and pre-calculate some of the properties that are needed during the rendering to save some render time and the memory usage as much as it's possible to do. But you have to know that this static text component can just have a static text that will not change during the runtime. And that's the disadvantage of it, but it's a bit faster and a bit less memory. It's using less memory, so you can save some resources by using that one instead of the classic text element. And this is about differences and how it looks in compared to the big Qt. Of course, there are a lot of types that are not available in the Qt for MCUs that are in the big Qt and the normal Qt. But of course, those are simply not supported at this point. And we won't cover every of it, as it's a great set of those. So right now, let's go to styling controls and how you can provide a custom style for your button or any other user control, the default one. So there is a way to define an in-place styling, which simply defines the style in the place in the QML where you are using your, let's choose that button. And this is fine if you are going to style one function, one control exclusively, as if you would try to use that way to style all of the controls, you will end up with a lot of duplicated code, and maintaining that will be a pain. So this is mostly for learning purposes or exclusive styling of one particular case. So it's rather something used more rare. And then the second option is to define your own component in your project. So generally speaking, it's just defining a separate QML file that will hold your style and will encapsulate your control with your custom style in the separate file. Then you can reference that file as a separate component in other QML files, and by this way you will share your style across different parts of your app. And finally, the most advanced way is to provide a style library that can be redistributed between different applications. And this is, as I said, the most advanced way of doing that, but that provides you a way to share single style library between different applications that can do different things and still hold the single style. But how this style is generally done, how styling looks like. Each control have set of properties that you can override to provide your custom style, custom appearance for parts of it. For example, the button have the background property, which defines how your button background will render for each button that is using your style. The same goes for the content item, which display normally the text in the default style, and so on for the other controls. There are some other properties like handle for the slider or the indicator, which you can override and provide your own implementation of the UI for this particular control. And let's look also on some examples. So this is how the in-place styling would look like. So you have some kind of QML code that defines some piece of your app, and then you have some button in it, and you are overriding the background property to provide the different appearance for it and in this case, it's just another rectangle. So your button will become a rectangle with some content in it. If you are going to share your style across different parts of your app, you can create own component, as I said, and this is the example of doing so. So you are you're embedding your style, so the control with override properties for the style in separate QML file, and then in other QML files you can reference that that component by just calling it with a name of the component file without the extension. So in this case, mybutton.qml will become mybutton component in other QML files, where you can still use that as a normal button with your custom style. And creating a style library, you can do that in two different ways. The simple one, as you can see right now on the screen, and by doing that way, you are saving some time in configuring the project in CMake, honestly. And it just differs from the previous solution that you are putting your style components in different directory, and then you are just importing that directory as a module in separate QML files. And by referencing that module, you can access your styled controls from there. And while using the custom style library, we'll implement custom controls based on just templates library, the templates module, let's say. And it will work, the implementation of those in QML will work exactly the same as in all previous ways of doing that. But the main difference is that those styles will end up in the separate library and will have its separate output directory with the artifacts from where you can then reference those, and from where you can link your library. And well, you can also share that library between different applications. And that's the main advantage of creating a library for your styles. Well, this is the example from the CMake, how you can set up your custom style library if you are going to create the separate library for it. So you are just adding the QML module with name of your style library. You're providing the URI, QML files, some headers if there are any, some imports that your styles are using, and then eventually you're adding the resources for that module. So if you are going to use some images in your styles, you have to embed those, of course, for your library as well. And finally, if you are going to create that library, you have to link that with Ultralite templates. And in your final app, you have to link with your library, of course, to have those styles linked to your app. And this is, of course, an example of it. So you are just using your library that is called MyStyleLib in this case. And well, yeah, you can always look on the default implementation in the example styling, which is the default implementation for those, and this is the one that we are using currently in our application that we have made yesterday during the live coding sessions. And well, if we are talking about live coding sessions, then let's start with another one in which we will learn how to provide that style for the controls. And let me open Qt Creator for you. And let me quickly prepare for it. All right. Okay, just to remind you how it works, yesterday I shared with you training materials. So if you don't have those, just let me know in the chat. we'll figure out something for you. And if you have those, then just keep in mind that if you were lost, okay, there is a question. There's some aspect of style that we tend to keep separate in constant QML or something like that to hold colors, okay? In this case, you're embedding all of that into custom components, and we are using them in terms of style to define custom controls with custom styles, right? Well, let me focus on this question. Yeah, right. So if you are going to create your custom style and that style is using some kind of as you said, helpers, constants, or so on, and then you are using those in your component. So well, you can either create free targets. So your app, you can create the style library, and you can create style module, let's say, which is the library, in fact, and the module with your constants. If you are going to share it with your app and then it with your styles, and you can link your app and your styles together with that library to have those constants available for both. So for your styles and then for your app. I think that's about this. Yeah, so basically you are embedding those. Well, so let's get back to the live coding session. So if you were lost during the last live coding session, so you have to go to directory 2, coffee maker step 1, and then let's pick just the solution, which is the state that I currently have on my device, and I will be starting from this state. And right now we are going to implement live coding from the step 2. And briefly, let's review what is included in the files that are prepared for this live coding session. So what do we have? We have some control for the slider already prepared. We have some additional fonts, and we have some additional resources. And let's look on those. What are those? This is an asset for the button, for the pressed one, and for the normal state. We have some knobs for the slider. We have some parts of the slider backgrounds, the default background and the field background. And we'll try to focus on including those files to our project. So let's copy those 3 directories, and let's get back to our application project directory, and let's paste that and replace the files if there are any to be replaced. Okay. Regarding the fonts, well, let's just keep in mind that we were using the Roboto family, and we just added the bold and the medium to our project, so we do not have to provide any changes in the CMake for those. Okay. Maybe let's quickly look on the CMake lists.txt, and let's add resources that were added during setup. Maybe let's fix the formatting there. All right. Okay, let's add new resources. Button down.png. Okay, there was a question. How can we add our C file project from our ARM compiler to Qt for MCU? Is there any option to generate C files from Qt for MCU so that we can add and generate hex file? And I'm not sure if you mean, if I got your question properly. So you're going to add your you're going to add the files that are auto-generated to your own project. Is that right? Because I'm not sure which C files you are exactly talking about. Because most of this stuff that is around conversion to C++ files from the QML files is done implicitly for you. If you could more precisely specify the question, I for sure will answer that one, but I'm not entirely sure I understand this. Well, so I will use that time to fill the list of the resources. Okay, and some assets for the slider. Oh, my batteries. Okay, sorry, just connect the power cord. Okay, I'm back. Slider background center left. Slider fill center. PNG. Okay, and it should be it if it goes about the resources, the new resources for our application. And we would like to maybe before we start looking into how to style the things, let's recall how our application is looking right now. So without adding any new QML files, we're just running the previous state. So yesterday we finished our application in that state. So we have some assets already there. We have buttons with the default style. We had a list of our coffees filled with the proper icons. There is also another small version of the logo on top of this screen. We were able to go inside the coffee properties screen, and there are some sliders, a button which is not working yet, and the back button which is working. Well, right, so this is the current state. Let's review that on the device. I have already flashed, so we don't have to wait for it. So exactly the same for the microcontroller. All right, so well, it works. Okay. And right now we would like to provide a style for our button to have it more fancy. Let's make it more similar to the rest of the icons and the colors. And to do so, we will add new file. So let's click right on the project, add new, Qt QML file. Choose. Let's call it button.qml. Okay, you don't have to provide the extension, but we would like to create it in the directory controls. Select folder, and let's click next and finish. New directory should appear there, but just after we will add this file to the list of the QML sources. Let's fix the formatting a bit. Okay. So in QML sources, we are going to add controls/button.qml. All right, and it should appear on the left side in our project in a while. Okay, it's there. It's of course empty. Let's open it. And well, so right now it's just an empty item. And let's think how to implement that button. Well, so with for sure one item, we will need button. And to use the button, we need new import. Quick templates to 0. All right. Okay, let's give it some ID. And well, we will add some paddings, margins, some width, height. And before I will do that, I will show you the difference between the different layout properties in the styles. And to do so, I will open the documentation. So here it is. And we will be defining some custom styling by using those insets, paddings, and the height and the width. So as you can see, the top and the left insets are just the space between the real size and the background of our control. The padding refers directly to the content item, and this is a separate property to define your control style. And of course, the height and the width is a normal size of the control that is covering the part of the screen. All right. So let's now set those paddings things. Top padding. Let me 7. Bottom padding 7 as well. And left, right. Not left, right. Left padding. Left padding will be 10. Right. Padding also 10. And some insets. Top inset 2, bottom 2, left inset 5, right inset also 5. All right, okay. Okay, and well, so we will need the implicit width and implicit height properties. And why those are implicit? This is a special property to define the recommended, let's say, recommended size for your control. And if you are not setting the width and height, then the implicit width and height will be used for defining your control size. And for us, it will be a bit complex. Implicit width will be max of from background, if it is. Implicit width and if it's not, it will be 0. All right, so this is it, and plus left inset and plus right inset. Okay. Or it will be content item if it is. Content item with or 0. Left padding, right padding. Okay. Well, let me look on this for a while. Okay. Let's go back. Right, this is about implicit width. And the same for the height. Unrelated question, where we can access the recording to yesterday's lecture. It will be available for you after 2 days training, both at once, maybe not just after the meeting. You will have that in your emails, I think in maximum 2-3 days after the training will finish. All right, so there is the same for the implicit height. Okay, and then there we will create some read-only property just for convenience. Real text pixel size 18, and let's keep the text color as an alias. Alias just refers to other properties in your application. Sorry, in your QML file. And that alias will refer to our content item, to the control that we'll put into the content item. Content item will hold text, an ID, button text, and this text color will refer to button text color. Okay. And right now, let's fill that button, that content item. Button control text. So we are referring to the button in the root by just calling the button control text. And let's change the font. Sorry about that. Oh, pixel size is the button control text pixel size property we have created before, and its weight will be bold. All right. Horizontally align this to not this one, to text horizontal center. Okay, and still we will need some background. Okay, with the source, and we'll define the different asset. Depends if our button is pressed or not. So once more, we refer to the root button control down. This property holds the information about if button is pressed or not. So if it's down, then it's pressed, and then we are choosing the right asset for it with QRC. Okay, button down.png, and if it's not pressed, QRC button normal. All right, there is a question. Well, let's say we have 2 teams. No problem. I thought that it's Ultralite. Okay. Okay, let's try to build that to see if I didn't break anything. Okay, seems to work, at least for now. And let's try to use that custom style from the button in our splash screen. So to do this, we have to replace the default button with our implementation. And to do so, we'll replace the importing of default styles library with our directory. So I will import directory controls as, let's call it Coffee Controls. So right now my controls directory becomes Coffee Controls module for this file, and I will refer this Coffee Controls and button, which is inside Coffee Controls module. And let's try this. And hooray, we have our new custom button directly in our splash screen. But as you can see, still all other things are styled with the default style. So we are just about to change that. Let's go to Coffee Parameters screen and let's replace default styles library with the same. So let's import controls directory as Coffee Controls. And right, let's look for the button which is there. Okay, and let's refer the Coffee Controls module and then the button. All right, let's try. Start, and we have that custom style for our button also in the Coffee Parameters screen. Well, so simply it works, and let's verify that on device. I'm hitting run and I'm switching the camera. The board is still flashing. We are still adding new resources, so the flashing process will become longer and longer within each asset that we are adding to our application. All right, and the same styles are also displayed on the MCU device. As you can see, the button is changing its color. So in fact, the asset, while I'm pressing it, and still the sliders are not styled, and we are going to change that. Okay, so let's open the cmakelist.txt file and let's add the previously prepared slider style from the controls slider.qml, which defines the style for the slider exactly in the same way as we do that for the button. Let's review the QML file for it. So what do we have here? We have exactly the same imports. So we are importing templates. We are just defining the slider in the root, and we are overriding some properties. So there's implicit width and height. We are setting some default values for other properties like from or the step size, and we are overriding the background property to provide a different style for the background. And as you can see, in this case, it's a bit more complex as we are combining the background for our slider from different parts of it. So there is the left and the right part of the background, and also the center part, which then is adjusted to needs. So depends on how far your knob is in your slider, then the center part of the background is scaled horizontally to fit the amount of the space that is needed to draw that background. And by doing this, we are favorizing the application size. So we are not adding the assets that are big or are delivered in different versions. So we have small assets, and by scaling those, we are reducing the amount of memory that our application is using for those assets, but as well we are providing the flexibility of those controls, and then we can have any size of it because we can scale it up to our needs. So this is how it looks, and this is the background for the normal black background, and the other part of it is for the filled part. You will see the effect later on, and for the handle, of course, there is another item defined with an image different for the pressed and not pressed state. So right now, let's try to use that in our application, and let's see how it works. And right now, let's go to Coffee parent slider file. And as well here, let's replace the default styles library with our controls as Coffee controls. And in slider, we just have to refer component from that custom module. All right, let's verify that on desktop. Let's hit start. Let's choose espresso, and clearly it's visible that we have a new style for our sliders, and by just providing a single style in single place, we overrided default appearance for those previously blue sliders. We just right now have sliders based on some assets, and for sure it looks way better. All right, and right now we do not have any more controls that are using default style library, and to prove that, we can remove linking to that default style library, and we can just leave the library with templates, which provides the raw skeletons for the controls. And well, to do so and to prove that we are not using default styles any longer, we just have to go to cmakeLists.txt file, and let's find the target link libraries. And there is Quick Ultralite Controls style default, and we have to replace that with Quick Ultralite templates. Okay, let's save the file, let CMake to be reconfigured, and let's run it again. Here it is. So let's click start, let's choose some coffee, and as you can see, we are no longer using default style library. We are just linking with raw skeletons without any style, and we are providing those in our application in the controls directory with custom components. Then we are referencing those in our files by just importing our directory as a custom module, and by referring that module, we can access those custom components and use the custom styles directly in there. And the last thing to do is to verify that on the device. So let's switch the kit. So let's click that MCU icon. Let's pick the NXP 1050 board and release, and let's click play. I will switch the camera as always to show you that it works on the device as well. Of course, the flashing process will take some time. board is still flashing. We need still a bit more. All right. So here it is. Exactly the same application works on device as well. And you can see that the styles for the sliders are different here as well. Okay, there is a question. Let me just get back to the presentation and I will answer it. The warning messages we see in the IDE, are those okay to ignore or should they be addressed eventually? Well, currently, Qt Creator has an experimental support for Qt for MCUs, and that was also visible in the plugin for it. So development of the support for Qt Creator is still in progress, and we are improving that from release to release. And some of the errors like this one, well, it's not okay, but we have to live with it for now. But as long as your CMake projects are reconfigured properly and the compilation process works without any warnings or errors, it's okay. And we are still working on improving that. And there is a second question, which class might go into interfacing with the hardware to control devices to adjust the temperature and such of a device? Which class might go into interfacing with the hardware to control devices to adjust the temperature? Okay, well, you're probably asking about controlling the real hardware. So, for example, you're going to create some steering mechanism for something, and you're asking about how to send some event to your backends or something like this. So, well, we will talk about communicating between QML and the C++ later on today, and probably this topic will answer your questions. So there is a way to connect your C++ code together with your backends and so on. Is there a Qt training event that discusses drivers and hardware and interfacing with the graphical user interface? So as I said, even today we will cover some parts of your questions. So at the end of this training, there will be a last live coding session and some background of it, how to connect your C++ code and how to send some events from the UI directly to your C++ implementation, which can be then connecting to your other things like drivers, for example, and other hardware features. There is no dedicated Qt training for it yet, but there are some more advanced Qt trainings in plans. But well, no, for now, I don't know exact dates, so I cannot say anything more. But hopefully I will answer some of your questions later on this day, while we will be talking about some more advanced things with communicating to the C++ code, which of course can then be connected to drivers or the hardware or other components in your whole ecosystem. All right. Right, this is about styling the controls, and in our agenda there is a time for a short coffee break, and before going on that coffee break, I will just ask again if there are any more questions. I can answer those directly right now, and if not, then we will go to get some small rest. I will slowly prepare the timer for our break. Okay, I don't see any more questions, so let's meet each other in 15 minutes. I'm just starting the timer right now. And, well, see you soon. Okay, welcome back after the break. And in the meantime, there was a question about developing the Qt for MCUs application independently to the other team that could implement different components of the hardware. And well, I answered that question in the text form. So just let me know if there are any more questions regarding this one. But typically, the case is that that you are just compiling Qt for MCUs application as a static library, and in most cases you are exposing just a single function to start the Q app or to initialize and then start rendering, and you are just calling those two functions from the static library in your final application. And generally speaking, you can work independently on that library, and then you can just switch the library once the UI is ready. Well, this is a way that typically the products are made using the Qt for MCUs. But let's focus on next topics. So there is a topic of internationalization. So the topic of translating our application to different languages, and this is how it works in general. So it uses the same Qt approach. So it uses the Qt linguist tool to provide translation files. It also uses the QSTR function to mark translated text. And there is a short example of providing a text that will be translated in the text component. So instead of just providing a string in your text property for the text, you are providing it through that function, which will provide your translation. And for those who don't know how Qt Linguist workflow is designed, on the right side, you can see the diagram which will explain for you. So let's imagine you are creating the new application, exactly the one that we were creating yesterday at the beginning of our training session. There is nothing. So once you're adding new content to your application, you're as well adding the text to the controls, to the text or the static text components. And then during the compilation time, our linguist tool is parsing all of those QML files to search for strings that are marked with the QSTR, and then it creates translation files or updates them if they are existing already. Then if you are going to provide custom translations for strings that are not yet translated, you are using Qt Linguist tool, which is a pretty good way to explore those translation files, to understand what is the context of those translations. And of course, it's a tool that can be easily used by, for example, translations team. You don't have to be a technical guy to understand how this tool works. Then after updating those translation files, you can build your application with those. And our build workflow is embedding those translation files in the binary form in our applications. And then you can release your app to customers in the form that you are going to do so. And for the next updates for your application, the workflow will repeat. So you will add new content. So for example, new text elements somewhere, new strings. Then during compilation, Qt Linguist tool will update your existing translation files and will add empty fields for the strings that were not there before. And then there is a time to translate those missing things and build your app again. And then you can release your app. There are some limitations around those. If it goes about Qt for MCUs, translations from the C++ level are not supported. So if you have any interfaces written directly in C++, you cannot use QSTR function there because there is no QSTR function in C++ APIs for Qt for MCUs. And Qt Linguist tool will not parse your C++ files. So this is simply not supported, and you cannot use that way. In Big Qt, there are other functions than QSTR. In Qt for MCUs, there are not. So you have to use that single one if you are going to provide any translations for your application on Qt for MCUs and on the microcontrollers. And plural disambiguation is not supported in translations at all. Well, and for now, we have to live without this feature. This is the next thing that is a bit different from a Big Qt. So in Qt for MCUs, we have a global Qt class, which is available to all QML files. You don't have to include anything special to access it. And there is a property UI language, which holds currently set language for your app. And this property is read-write, so you can use that to verify which language is set, and depends on the particular languages. For example, you can choose to change some assets to modify your UI, for example, in the language settings to show which language is currently set. And you can use that property, global property, to update your current language. So if you are going to change the language that is currently used in your app, let's just then override the value that is currently in the UI language. And normally, when no translation is applied, this value is empty. From the CMake side, there are also some macros to embed your translation files in the application, so you don't have to do that manually by yourself. And to define translation sources for your app, you will use cool target embed translations macro, which creates another target for compilation, update translations, which has to be called before the compilation to update your files, or your translation files, and to parse your QML files, to search if there are any new strings to be translated in your TS auto-generated files. And this creates and updates the TS files, as I said. Well, and to and simply the embedding of those translation files finally is also included in that macro. Well, and there is a rule that there is one translation file for the one language. So for example, for the German and for the Japan, in this example, you will have two separate files that will hold separate translations for those. Well, and you can wonder how it works together with glyph management. So maybe some of you remember from the yesterday training, Qt for MCUs generates glyphs only for the strings that are detected during the compilation time in your QML files. And you can wonder how it works if the user is going to put some custom input, for example. You can simply extend Unicode coverage by overriding the property font Unicode coverage in the text. And well, then you can provide, for example, the Unicode block by providing the enum value, which is the full list is available online in documentation. And you can add some more and extend Unicode coverage with the Unicode block for a given region. For example, the Canada is here. You can, of course, add some particular value, exact value of some single glyph that you are going to include in your app. And you can provide an arbitrary range between two values in Unicode in which you would like to have the coverage included. And this is how it looks like. So this is an example of extending that Unicode coverage with Unicode block for Canada, and then with one exact Unicode character and some range. And this is how it works. And right now we'll try to do that by ourselves, and we'll learn how to support multiple languages in our app. And then we'll go to the lunch break. But right now, let's focus on providing translations for our application. All right. Once again, we will get back to our beautiful Qt Creator, and let's wait a bit. I will prepare for that. Okay, it's this one. All right. As always, we will review the files that are prepared for this live coding session, getting started workshop and the materials for it. Okay, step 3. So for Coffee Maker, step 3. Naming can be confusing, but it's there. Files, and let's review the files. We have some new style for the radio button. We'll use the radio button to switch the language. There are some updates for the helpers. We will have new resources. As you can see, those are for the button, for the language change, some for the radio button style, and some background for language selection pop-up, some updates for other files, and well, let's copy all of those. Why it's not working? Because I'm not clicking the proper button. Okay, I copied that. Let's go to training, Coffee Maker, and let's paste and replace the files. All right, let's close that one. And we are ready to add new files to our CMake project. So let's go to CMake lists.txt file. And let's focus on adding new resources in there. So in the Q add resource macro, let's extend the list of our resources to include the button, language normal, resources button, language down, resources language selector bg png, and resources radio off and radio on. Radio on PNG. All right. Some new QML files. The one for the controls. Controls. All right. Radio button.qml. This is for the controls. It should appear on the left side. All right, it appeared. Okay. And the files from the root directory, language button, language settings, and language radio group. Okay. All right, and we are going to define our translation files. So let's go somewhere below, and we have to define our translation files. Oh, well, maybe let's go under the module just to make sure that the module will be visible as well. We'll add translations by calling the macro for it, Qt target embed translations for Coffee Maker. And I would like to have translation de.ts and translation fr.ts. So we will translate our app to German and to French. All right, and we are going to provide translations not only for the Coffee Maker, and translations will be needed as well for helpers module. So to provide those as well here, let's create translation files as well for this helpers module. Those will be this single translation files, but just to tell our Qt Linguist tool to cover QML files as well from this target, we are just calling this twice. Okay, the CMake project is regenerated, and right now we have to add some custom build step to make sure that every time before build, our Qt Linguist tool will parse the QML files And then we will be sure that after the compilation, we have included all even empty translation files to our application sources. So to do this, let's go to projects on the left side of the Qt Creator window, and let's find the targets that the kits that we are using. Let's focus right now on the one that is currently selected, so on the NXP 1050 kit. And we are going to provide the custom build step for it. And this is done in the right side of that window. Let's find build steps, it's there. And we have to add a custom process step. Here we have to provide CMake. So we have to trigger this CMake target, in fact. All right. Okay, we would need probably to find that CMake. All right, okay, so our Qt Creator installation won't find the CMake as it's not included in my path. So I will just point to exact installation directory that is in Qt installation directory. So I just go to C, Qt installation directory, tools, CMake, binary, and there is a CMake.exe. Okay. And right now we have no problem with searching that. Okay, and in arguments, let's put -- build dot for current directory, and let's pick target, which is update translations. All right. Okay. The working directory is the build dir, so by default. And the last thing here is just to put this custom build step to the top to make sure that it's run at the beginning. And let's do the same for desktop. So we will have a time to do this once again. Just open the build section for the desktop kit. Then on the right side, let's find build steps. Select add build step, custom process step. In the command, let's search for your CMake, which is delivered together with Qt installation. In my case, it's C Qt tools CMake _ 64 bin, and there is a CMake.exe. In arguments, we are typing -- build. I thought that there will be a question, so just let me finish that and I will answer that. Target update translations. All right, and let's put that to the top. And I will go to the question and answers. What the update translations will do is go through your QML, find all QSTRs and add them to the translation file while keeping your previous translation intact. Exactly, this is what update translations will do. And with that assumption that if the files are not there, it will create it. So, well, if you don't have any translation files, it will create those from scratch and fill it with the missing translations. And if you have already some files, as you said, it will just update the file with the missing things and will still keep your previous translations in the form that it was before. So I think it's as expected. Okay. Okay, so we could try to build the application, because right now, just to verify that, we won't have any translation files. Let's open the training directory and let's show you. So right now there are no any translation files in our directory, and we'll try to see if our update translations target will work. So just let's pick desktop release to do this faster, and I will just hit start. And it's not working. Okay, so let's see what's the problem there. Unknown argument target, so probably I missed some dashes there. Let's edit that one. Double dash there. Okay, let's try again. All right, yeah, that was the problem. And I probably did the same for the NXP board. So once the compilation will finish, I will, yeah. So right now there is just a small change to our application, that there is a new button for switching the language. Let's click that, and right now you can see new menu for switching the language between English, Deutsch, and French. German, okay, Deutsch is in Deutsch, and you can switch the languages, but nothing is happening right now. So this is just a step for our things. Let's close that one, and let's fix shortly the another target. So I forgot to put double dash there. So double dash build dot double dash target, and right now it should be fine. All right, let's review the files that are right now generated here. So as you can see, those new translation files are right now available for us. I will open those in Visual Studio Code. Okay, and let's open one of those. And what it is? This is a simple XML file that holds our strings that are used in our app. Besides the raw strings, it holds some comments, it holds some location from where that translation comes from. And that's a pretty useful thing. So let's try to find our start button string. And let's, where this is, okay, it's here. I'm right now searching for start, and it's not there, and you can wonder why. And I'm going to explain it to you, because our splash screen is not using QSTR right now, and we are going to fix that problem. And then this will be directly referring to the question that we had before. Then you will see that our tool will just update the translation files. So, well, simple, let's do that. QSTR. Okay, and well, let me fix all of those missing QSTR places. So I will just search for it in the whole project. Okay, find in all projects. Okay, search for text. And search. And well, let's trust me, I remember a bit where those were. So coffee parameters is the first one. Let's go and fix that one. QSTR. I'll copy that thing. All right, save the file. Okay. Then there is a language settings. 2 strings there. And the second one is the save button. Save the file. In the splash, we already did that. And helper functions. Let's see what's happening there. All of the strings are translated to QSTR functions, so there should appear in our translation files. And There is one interesting thing, as you can see, there are separate arguments, additional arguments to some translations, and those are pretty useful things. As in our, for example, splash.qml, we are not providing it. And here those are added. And let's just rebuild our app to reconfigure and regenerate the files. And let's see what happened to those. Still taking a while. Oh, sorry. Okay, it's still building. It is, oh, well, I selected the board. Okay, that's why it's taking a lot of time. So I will stop that. I'm switching the kit to desktop one, and right now I will start that. It should be a bit faster. Right, so no change there yet, but let's review the files. So right now, if I will look for start, it's clearly visible that the start string is located in our translation files, and it's also coming from the splash.qml file from the line 24, what is of course truth. And well, right now let's look on Qt Linguist tool. That's it's also an interesting tool from the Qt. So let's minimize the Qt Creator and let's open Qt Linguist. If you are typing in the search in the Windows 10, you can just type Linguist. It will be easier. Sorry for Polish translations there. I'm not sure why it's still happening to me. It probably took the region instead of this language for the whole system. But well, let's open those files. And let's open the translation file for German language. Coffee maker and German. And here it is, how it looks like. So on the left side, you have the components. So for example, our splash screen. And in the center, you have a list of strings that are about to be translated. And on the right side, you have a reference to the source code and to QML to see what the string is coming from, where the string is coming from. And on the bottom side, you have the place to translate those strings finally to the target language. And let's focus on the helper functions and let's see what that comments are doing, that secondary arguments for QSTR function. Those are providing the context for translations. So for example, you don't usually you don't know what the single word can refer to and in which context it was used. So the person that is developing the product can provide that context in additional argument, and then someone who is translating your app, your strings, can refer to those comments and can understand in which context particular word were used. And that's a pretty useful thing to provide high quality translations for your apps when working with distributed teams of translators. So this is a pretty useful feature that can help you provide better quality for your apps. And well, let's try to translate the language settings and the save buttons. So for the language settings, it will be, I will be honest, I'm just copying that. I don't know how to translate those. And for the save, it's that one. Do not forget to save the files. Just let's click that floppy icon. All right, and right now we can close that and let's get back to Qt Creator. And let's try to run it to see if our translations are working fine. All right, and our translations were coming from our new language setting screens, and we were translating the header for it and the content for the buttons. So let's try to fix, to change the language right now. And as you can see, the new translations, which are coming from translation files, are right now displayed directly in the places where they are used in QML files. Well, so still rest of the things are not translated, and we are going to fix that right now. So in our training materials, let's go to, this is a step 3. So let's go to solution, and there are the full translations already. So let's copy those. And let's replace those files. And we can try to verify that once again. All right, so by default, we have English language. So let's review what strings do we have there. So we have the language code there. We have a language settings header, some languages that won't be translated. We have a save button with a save string. In the coffee selection screen, we have some strings to describe the parameter type. We have some values for those, like medium, mild, very strong, strong, low, medium, high for temperature, and the start button, which is still not working, just to remind you. And let's try to switch the language to German one, and let's see what happened to the parameter screen. All of the strings already are displaying the content with a different language, and those translations are coming just from those translation files that are generated during the compilation time. Start, of course, is the same in German, so that's not a bug. Let's verify that with a French. All right, as you can see, it works. Okay, so if it works, then just verify that on device. Let's run a compilation. It will take a while, so maybe you have any questions to this. Just please feel free to ask. Okay, the flashing process has already started. So I will change the screen to secondary camera. It's still flashing. It's just the old view. We have to wait a bit still. Also, translations are expanding your app if it goes about application size. So those strings are located in your flash memory, in the binary form. So the flashing process will take a bit more. Okay, it's there. So let's start the app, and finally we can see our new screen for changing the language, and let's verify if it works for French. It's hard to click. Okay, it seems to work. Let's verify that on the parameter screen. It works as well there. Let's change. Okay, perfect. Let me get back to the presentation. And as I said, Now is the time to go for the lunch break, and I'm just right now setting up additional timer for it. And we'll have 45 minutes instead of 15. And let's see each other in 45 minutes. Okay, welcome back after the lunch break. So let's start. Maybe let's continue with another topic, the last topic for today, but probably one of the most interesting topics: how to connect your QML code with C++, and let's call it C++ integration. Probably it will answer some of the questions that were appearing during the training. And here you can wonder why you would like to use this C++ code if you have the QML language to define the UI interface. But as we probably all know, the microcontrollers world is not just an UI, it's mostly everything around. So the UI is just for showing some status or to allow the user to manipulate some features, some other components of your ecosystem. But to do so, you have to communicate with that component somehow. And that's where the C++ integration comes to the game. So to connect your business logic and to perform some input and output operations with the hardware and potentially another peripherals and components in it, you will have to use C++ integration to pass events, some touch input, or in general interaction from the user directly to your other components, the lower layers of your app. This will also show you how to provide the custom main function instead of having that default one that comes with Qt for MCUs. And how it works in general, how to communicate between QML and C++. So you can export C++ class declaration to QML component. And this is done in general implicitly for you. You just have to tell Qt for MCU which classes you are going to expose, and that class or the struct has to inherit from QL object. And that's the only requirement. And then during the compilation process, your headers will be translated to QML interfaces that are needed, in fact, by our internal tools to for the generation process of other intermediate files. And you just have to know that this is happening. So if you have a header file that you are going to expose to QML, it will internally in the build processes translate this header file to the QML file that is a mirrored class from the C++ to QML. So as you're looking on the example here, this struct big state with some properties, signals, and the function will be translated to QML file bigstate.qml, which contains the Qt object with a property of the same type and the same name, with the function of the same declaration, and the signal with the same name and the type of the function that is going to be used there. And that's simply how it works. Let's dig in a bit. So to expose a property, you have a separate class for it, and that has to be public field of your class or the struct if you are going to expose that from your C++ component. And in this case, this is a template class. And if you are providing some argument in the template argument, this will become the type of your property on the QML side. So let's look on the example. If you are exposing the property of type int, and it's called strength in the QML, you can access that property and override or manipulate the data in it with other integers there. And on the right side, you have an example that on clicked event is just switching the value of strength to 100. The set strength function is not needed there, to be honest. It's just to show you that also you can expose some function instead of just exposing the property. For convenience, you can group your properties. So inside your exposed component, exposed class, you can create another struct, which internally, if it's internal to the class that you are exposing, does not have to inherit anything. It's just a container for other properties that you are going to expose grouped, and that group will have a name of the property that you will instantiate, the property of that type that you will instantiate in your struct or class. Just remember to have it public. And on the right side, you have an example that by using the power source name for the group, you can access the current and the voltage directly from QML, which is a pretty useful thing. If it goes about mapping types from the C++ to QML, of course, there is some mapping. And as you can see, the bool is just a bool on QML, and some integral types like the char, short, int, and so on will become just an int on the QML side. Floating points, all floating points and floating types will become real on the QML type. STD string is just a string, and all of the T's that derives from Q object will become a T component type. The T pointers, sorry, will become a T types on the QML side. So if you are going to expose some class that is called, for example, my class, and you are exposing T pointer, so my class pointer, it will become just a QML component, my class. Simple as it. And the enum is just an enum. If it goes about exposing the functions, of course, they are allowed to have some arguments. In this example, you can see that there are 3 functions that are public in this struct. This, for example, is even a singleton, but we'll cover that later on. You can use other classes or templates from Qt for MCUs C++ APIs to provide more advanced, let's say, interfaces that could be some containers, some can implement, for example, the singleton pattern. And of course, if it goes about singletons, it will be available in the whole project in every QML file. And the another thing that is important next to that requirement that functions has to be public if you are exposing those, it also has to be non-overloaded one. So that 2 requirements are strictly tied to exposing the functions. And of course, those can have the return type. So just notice that isLetOn function that is also exposed on the QML side can be used to get some status. And in this case, it's just returning a bool. To expose a signal, you have another template class that you can use for that. This class will be translated exactly to the signal that is known from the QML. We were using that for example, to pass the touch event from the button on the splash screen to the upper layers, to the other QML files. And this is exactly the same thing. So on the C++ side, you just have to define the field, the public field of your class that is going to be exposed. And then this signal will be available in other QML files that are using that exposed interface. And still, it will be possible to handle some signals by creating on signal handler, and it will be still possible to call that that signal from C++ and from QML as well. Well, I said that before, but just for convenience, I will repeat that one. If you are going to expose something that is globally available for all QML files, you're just probably going to implement the Q singleton case. And that's another example of it. You can, of course, still expose properties and so on. And well, if you want to expose C++ data model to QML, so it probably could have some dynamic data that comes from, for example, from the web service in your product. You could expose that from the C++ directly to QML by implementing, for example, list model template. And your class that is your model has to inherit from the list model of the given type, and that type is a type of the single item in your model, of course. And besides that, you have to override two main methods for your model. It's the count that returns the size of your data that is held currently in your model, and accessor function for the single item based on the index has to also return the single item of the type of your type that you have provided in the list model template during the inheritance for your interface. Of course, still such a model can expose additional properties, additional functions. In this example, you can see that besides those two required functions that you have to override, there is the add function exposed that takes some string and the price, and you can update your model also from the QML by just calling this add function, and that's not a problem. There's one thing I have to say about this, because this mechanism is not perfect, and if you are going to update your model quite often, it can be too heavy for the microcontrollers, as currently updating your model in the C++ will require calling model reset function. This thing also you can see in the add method, and this call is causing redraw of whole control that is using your model. So, for example, if you have a list that is displaying the things from your list model, and you are calling the model reset, then the whole bounding box of your list view will be redrawn completely from scratch. So this can be a heavy thing if you are going to refresh your data quite often. So that's the thing that we have to remember right now. We know that's maybe not so convenient, and we are working on improving that thing. But currently, and in the 1.9 at least, it still be the same. But well, you have to trust me just that we are working to improving that, to have the possibility to just redraw the parts that really needs that. Well, but that's just related to that one model, which is causing refresh of the whole list view in the example on the right. But normally, Qt for MCUs, of course, just redraws the places that need redrawing to be as efficient as it's possible. All right. Previously, I said that we'll see how to provide the custom main function. So if you are going to create your own, for example, because you need to initialize something more than just the graphics components that Qt does for you, you can create your own main function, and you can just put your specific initialization of the components you need for the other things or other components that you are going to use. So then you have to just remove the CMake API that we are currently using in our application, so the app target default main, which provides you default implementation for the main function. And then you just have to define your own implementation in separate C++ file in your solution, and just compile that together with your app, and that's all. The only thing that you have to remember is to call this set of the functions that you are currently seeing on the screen. That's the case for the bare metal, of course. So you have to call Qt init platform, then you have to initialize the application instance and the root item. After we have those three things, it's just the last thing to do is to set that root item and execute the exec function, which is the endless loop, and will start rendering the content of your app. To manage some events across different parts of your app, there is a pretty useful mechanism, event queue of a given type, and that type is a type of the message that you are passing between different components in your application. And those components are not only the UI components, where I mean, if you are going to, for example, pass some events from the QML code to, for example, another C++ component that holds and manages your, for example, I don't know, Wi-Fi connection, and you're passing the event which network was selected, you can use event queue and send the event from the QML code to other C++ parts without any problem, and the Q runtime will take cover of passing that event to your endpoint, and this can be somehow configured as well. So you have some overrun policies. So if your event queue is right now full, you can decide what to do with the events that are still coming to your queue. So you can discard the new events. You can override the oldest. So then you're just discarding the oldest one, and the new one is going in that place. And well, there's also the override. There's also a function that you can override in the event queue to know when the queue is overrun. Of course, you can also control the size of the queue. So if default 5 events is too few for you, you can always bump up this to the number that fits for you. Important thing is that order of the events is kept only in scope of each queue. So, for example, you have an event queue with a message, well, let's call it user message. Event queue over type user message has guaranteed order only in that type. So if you are relying on order of the events, you can think of creating a single type event queue, or you can provide your own synchronization between different types of the queue, but this is not provided together with the Qt for MCUs. And this is some example of using the event queue. So let's look on the left side, which defines this struct with a type of your event. So this is some input event that will hold an information if user pressed a key or released a key, or pressed the screen with a touch. And there is some union, of course, based on the type. You decide which field you should read. And on the right side, there is a definition of the whole queue, which is the input queue. Of course, it inherits the event queue with a type input event from the left, and as well for the utility, it also inherits the singleton in the same time to make it globally visible for the whole QML part of your app. This exposes some signals that you can watch in your other QML components, for example, for key press, key release, or touch event. Of course, you can distribute that event to other C++ parts of your code that can be not related really to the Qt for MCUs, but you can see that on event function is overridden there, and you will receive all events that are coming to the queue directly there, where you can analyze what's inside your message. And here's the example of some simple switch that will check for a type and then decide what to do next. Well, this is another part of the same example. Same example? Yeah, the same example. So, for example, you can have some interrupt handler in which you are waiting for the touch events, and in that input interrupt handler, you can call your input queue, and there you can build your event and post that event in that queue. Then in the QML code, you can still watch your queue by just defining on key press, on key release, so on signal handlers with a correct logic for your app. That's also not a problem. It works across QML, C++ in both ways. So that's still not a problem to use event queue everywhere. where you only need. And right now, we'll try to use some of those features in our coffee machine, where you will learn, of course, how to create C++ object and how to use that in QML, and how to create a list model in C++ and how to pass elements that are held in the list model. And we have a question, so I will try to answer that one. Okay, are there internal events in Qt for MCU that we have to account for when we create event queues, or only our events can make it through the ones we create? Are there built-in touch, release, drag type of events? Okay, so currently platforms are relying on event queues. So there are already implemented event queues for a touch. So every board that supports touch currently in Qt for MCUs, from the boards that are supported by default out of the box, are using their own so Qt internal Qt for MCUs internal queues for passing a touch events, and Qt for MCUs is watching them. But it's not a problem. You do not have to take those two into account. You can always disable those. That's not a problem, and you can provide your own. And as well, you can create your own event queues next to those, because this is not interfering with each other. If you are going to create event queue of different types, so with different message, that means exactly, then you don't have to worry about anything, because in your event queue, you will receive only your events. Only your defined messages will come there. So I would say there is no sense to worry about those touch queues that are in the Qt for MCUs currently in the platforms, because simply it does not interfere with each other. And well, yeah, the last question probably I already answered. So there are already touch, release, drag events, but those are mostly exposed to you in the QML as signals in the controls that you can watch. So for example, the button have the signal on long press, for example. On release, you can watch those events. So you don't have to use the event queue for that. But of course, you could. That's possible. You're welcome, no problem. So right now, let's get back to the Qt Creator. Now let's verify that after the lunch break, we have still working application, as we never know. It's a live coding session, of course. Okay, it's building, and here it is. Perfect. So just to remind you, after the lunch break, we have the splash screen ready, we have styles for our controls, we have translations ready, so we can right now talk in French. It's not a problem. Well, maybe problem for me. But well, this is the current state. This button is still not working, so we are going to implement that one, and we'll have to implement the history view. So there will be another button with a history that will hold information about our last prepared things. So those two things will be connected to the C++ backends. So the brewing will be simulated in the C++, and the history will also be held in some C++ containers. We'll probably use some vector for it. And let's try to start with implementing those new features for our application. Maybe let's start with adding something new, and we'll add the C++ file. So let's click right on your project. So on the coffee maker near the hammer icon, add new. Select the C++, and let's select C++ class. Okay, header and the C++. That's perfect. Click choose. Let's select some class name, and we will create a class. Sorry, my voice is once again not taking it. So first thing we are going to do is to simulate the brewing time, and to do that, I will create a brew timer. All right, and we have changed the path. I will create a source directory, src. Let's go inside, select that folder. All right, click next. We do not want any version control, so finish. This is a question if I would like to go to cmakelist.txt file. Of course I won't. And we are going to add some new sources to our application. And to do so, we are just using typical, normal, classic CMake API for it. So we are adding target sources for the coffee maker. And it's private inside the source. And the file will be called in that way, and it should appear on the left side shortly. Yeah, source files, and there is our brew timer. But before going to the file and before implementing anything there, let's create an interface. So let's tell Qt for MCUs that we are going to use that header as an interface for our QML code. And to do this, we have to use one of the CMake macros that are from the Qt for MCUs, qul target generate interfaces, and that's for coffee maker. And our interface that we would like to connect to QML is our header file, source brewtimer.h. Okay. All right. And I think we can go to implement our interface, and let's start from the header file. So I will do the trick there because the header file is not shown. So I'm going to the C++ file and click right and switch header source. And here it is. We are in the header file that is going to be our interface to QML. And before we start implementing anything to our class itself, let's include some of the headers from qul. Qul singleton, we would like to have this globally visible for sure. Singleton, okay. Include qul, what we would like to have their signal for sure to expose some events. So during the brewing process, we would like to simulate that brewing process has made a progress. We would like to know that brewing process has started and finished. So to expose that events, we will use signals. And also we will include qul timer. This will be helpful for us to just provide some delay for simulating the brewing process. And maybe some stdint for the types. All right, just to make it more simple, I will switch the class to struct and get rid of the public. Better, and let's inherit from qul singleton, and it will be of type brew timer. So of our class that is of our struct, to be honest, defined previously. And you can wonder where is the qul object, as it's the required thing. This qul singleton is inheriting from qul object internally, so we don't have to provide it right there. And right now, some more things. We would like to have a way to start brewing. So that's why we would like to create a function for it. Start brew. And let it be a bit more smart. So instead of just doing a simulation exactly the same for the parameters, for each parameters, we will parameterize that function to have a different duration for different parameters. And it will be strength. Those parameters are exactly the same that we have on the parameter screen in our app, so in these sliders. So strength, there is next capacity and temperature. Okay. Do not forget the semicolon there, and then signals. Qul signal. Okay, and that signal will be just a simple call, so no arguments and no return type. And we would like to know when the brewing has finished. All right, and another one for some progress. We already will know that brewing started because we are triggering it, so there is no point of creating a signal handler for it. Okay, and brew progress step. All right, to implement this simulation, we will need some more properties, but those rather are not going to be exposed. Well, then kill timer, and it will be a brew timer. And a tick count. Let's store how much far we are in simulation. So and we have a question. It looks like the brew timer is subclassing from a private kill singleton type that takes brew timer as its own template. Could you expand on that syntax, please? So well, if you are creating a struct, you are by default inheriting publicly. So this is not like in the class. So this is really that thing. I'm not sure if that answers your question or not. But this singleton is just, to be honest, well, implementing the singleton pattern for the brew timer class internally. So it's just to have an access to the instance that is statically allocated. That's exactly what the kill singleton does there. Just let me know if that answers your question. I'm not sure. So, well, let's try to build that. Oh, let's just click hammer. Okay, we are not sure about the how the template works there. Well, so let's look on the implementation of that singleton. So we are passing the type, the brew timer there, and then there is some places that this template argument is going to be replaced with our type. Yeah. Well, we are having the instance function that is returning the reference, the static instance function that is a part of that singleton that is returning the reference for our brew timer, which is internally the static object instantiated during the first call to that function, and then we will just return the reference to that internal static thing, and this initialization will happen just only once. Well, so this is how it works. Yeah, exactly. So this is just a pattern delivered to you to make things more simple, and well, the singleton is used probably in all projects in IT. So I believe it will be helpful to just have that template and just provide the type that you are going to implement by your own in that template argument there. Well, so I just built that, sorry. And right now I would like to show you how the conversion, the interface conversion looks like. So how the interface has been generated. So right now, just to remind you, we have added that in the Qt CMake APIs, and we told Qt for MCUs that this header will be used as our interface to QML files. And let's see what the build process does for that. So I'm going to the build directory of the desktop, which I have just built. I'm going to CMake files, coffeemaker.dir, and let's search for something that could be our interface. It's a B, so A, B, A, B, 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 B. It's not there, I can see that. Okay. Let's build it once again. It's for sure release, okay, don't worry. It should be there somewhere. Oh, well, it's there, okay. I just missed that. So let me put that next to our broodtimer.h and let's see how it looks. Oh my God, it's a tricky thing for me. All right, we have that. Oh, maybe not. Right now we have. All right, so the QML file that has been generated have inside are all public things that we are going to expose. So the start brew function with our arguments that are in int type, the strength, capacity, and temperature are exactly reflected on the QML side. The signals are also defined exactly the same way, so without any arguments and any return type. And our class even is a singleton there. And those things, in general, the whole file you don't have to care about because this is the pure internal thing, but just to show you that it's the real QML file that is converted into. And right now, our application will be able to see those QML interfaces by looking on that QML auto-generated QML files, and our tools will know that we have already C++ implementation for those. So our our QML to C++ tool will not convert that interface to another C++ implementation. We'll just use our classes to follow the logic implemented in the QML in other QML files. So other auto-generated C++ implementations will communicate with our implementation of the C++ just based on the QML code that is auto-generated there. And this is briefly how it works. But as I said, you do not have to worry about this because once you have created the interface and defined that in the CMake, you just have to write that interface in C++ and then use it in QML, and all of the magic is done for you underneath. All right, so let's extend that our application a bit, because right now we just have the raw implementation of the interface itself, but we do not have implementation internally, so broodtimer is empty. And of course, to save some time, we won't write our own timers and logic behind this. So our training materials comes with some prepared things, and this is the last step, so step 4. So let's go to the training materials, step 4, to the files. Let's review them together. So the helpers have some updates. The resources have some updates. So there are 2 new things for the history button. We have some implementation already for the broodtimer. So we won't be writing the logic for simulating really, but we'll just use the already existing one. Well, some additional updates for the QML files we already have, some new files for the history, and in the new files and the updates, we have new strings, so translations are updated as well. Let's copy those. Coffee maker, and let's paste that there. Replace, and here it is. Okay. It's just a question if we are going to update. Yes, we are. Now let's quickly review what's going on there. So we have some constructor implementation that just initialized the timer. We have some simple implementation of start brew function there, and well, some helper functions, some utility constants, and so on. Right, but this is something that we'll still cover later on. So right now, let's try to add those new things to our CMake project. Of course, we'll start from resources as always. Resources button log normal.png, resources button log down.png. Right, this is about resources, new QML files, history button, history list, well, and brewing progress and the brewing progress bar. These are the QML files for displaying the progress pop-up. Okay, and we have a question. Code generated from Qt is LCD independent. Right now we are using LCD available. Okay, the kit and the board, which is from vendor one. What if I change the LCD for vendor? Okay, is there any chance? Yes, of course. And this is a really great question, and this is the normal way of developing the product. Well, so normally at the beginning you are just buying the reference kits, and you are probably going to use Qt for MCUs to test if that works for you on that device. So this is the first stage, of course, and you are using the default screen that is that logic to handle that display is implemented in the Qt for MCUs platform implementation. So in the platform part, this is a separate part that is delivered in the separate library. And if you are buying the product, buying the Qt for MCUs, you're receiving the whole source code of the whole Qt for MCUs project, even for the tools that are converting the things, for the whole engine, for the whole platform. And so this is normal to modify the platform code, and it's prepared for that to fit the needs of new hardware components that will be switched to the in the real product. Well, let's say so. The platform is platform will still need some changes, but in general, Qt is written in that way that after switching the part that is responsible for updating the LCD, you will just have to update the screen size, and that's all. So 2 parameters for the screen size and just one piece of the code that handles refresh of the screen. So well, I did that by myself for other boards we have, and that was a pretty straightforward thing. It's just worked for, I don't know, if you know how the new display works and you have a driver for it, then it's just a matter of probably a few hours and you have new LCD integrated to Qt for MCUs. So that's the workflow normally. And of course, you will receive some help from our experts to solve all of your questions, so you're not alone with that change. Well, okay. All right, so we have our QML codes, QML files added. Still, there are some things to do there. We have to. What do we have to do? We have to add some more files to our interfaces, as there are more right now. Okay, let's maybe define the include directories. Target include directories for Coffee Maker. Is the public source. Okay, and we are going to add new sources. Source coffee model.h. I'm just adding the header file to the sources to make it visible in the source files there. Really, just does not need to be included there. Timestamp.h. Right, and we are going to use some more interfaces. Source coffee model.h and source all right, and here should be that thing. Okay, and let's try to build and run that one. Okay. So let's verify what's changed. And what do we have here? So normally the things we had before, there is a new history view, and there is right now still nothing there. So we will try to add some logic to trigger our new interfaces here and there. And let's try to open some new screens to make our app more fancy. And let's open the Coffee. Well, let me just check one thing. I'm not sure about one thing. Did we add source for this? Yeah, we forgot to add that one to compilation, I think. Yeah. Let's do it that way. Okay. All right. Okay. Let's compile that once again. Okay. Perfect. So let's go to coffeemaker.qml, and right now let's find the brewing progress. And this view is responsible for us for handling the brewing progress bar and for showing the status of our brewing process. And we are going to show that one and manipulate the state of it based on our brew timer we just created. And well, let's try to extend that a bit. And coffee parameters screen have right now a signal which is called once user is choosing the coffee parameters, and then once he's clicking start, the start brewing signal handler is called, and we are creating a signal handler for it on start brewing. And once the brewing is started, we would like to fade out a bit our coffee parameter screen. So its opacity will become 20%, and brew progress screen will become visible. All right. And well, we would like to start the brewing, to be honest. So we are about to use our brew timer. So just remember that it was a singleton. So you can access it globally, brew timer, and we can call start brew function that we exposed, and let's pass the parameters. Coffee params, the first one was strength, coffee params, second one capacity, and the third one temperature. Okay. And let's save that file and let's try what will happen. All right, so start. Let's pick espresso. Let's switch some things and let's click start. And what is happening? Nothing is happening, and that's normal. You can wonder, do we have a working timer? So let's review what's inside our brew timer implementation. So once we are starting the brew, we have the brew timer. We are setting the intervals, so how often our brew timer will make a step, and we are calculating that based on parameters. So step is longer, depends on the parameters. If they are well, higher values, then the interval is bigger as well. And then we are starting the timer. So on tick timeout, on timeout signal, on timeout lambda call will be called, and then we are just calling our signals there, which are the brew progress step if we are still not reached the finish, and it's also a brewing finished once we have all ticks in place. Not a fancy implementation, but it should work in theory. So why our code isn't working is because we do not watch those two signals anywhere yet. So we are going to change that right now. And we should do that in the brewing progress.qml. And let's go to the end, and we have the indication even there. So let's once again reference our brew timer, and let's create a signal handler on brew progress step. And that signal handler will do a step for us. So progress bar width +1. All right. And let's verify if that works. Keep it fingers crossed. All right. Start espresso, and I'm clicking start. And as you can see, the progress has reached the finish, and we are not hiding the progress pop-up. So we are just going to do this. In the brew timer on brewing finished. All right. And if brewing has finished, we would like to display different text. QSTR done, and the translation for this is already included in the files that are prepared for this training. So this is another information for translations. So if you have some strings that are translated in your translation files but are not used in the QML files, those won't be removed. So that's also an important thing. And there is also a local timer which will create some delay for closing that pop-up, because once brewing is finished, we would like to switch the text, but it would be an immediate change. So we probably won't be even able to see the string done. And to avoid that, we are calling some timer that is defined there internally to wait 1.5 seconds and then close the whole pop-up for us. So let's verify if that works. Let's click start, and let's be different right now, cappuccino. Let's extend all of the things. As you can see, brewing takes longer right now, and we have a done string, and the pop-up has disappeared. Still, just to prove you, history is not filled. And we can switch the language just to check if translations will work. It's in German. And of course, that's in German too. Perfect. And right now there is a time to add the model for our history view. So this is a good moment to ask some questions regarding those things we just did to our app. So to some brew timers, to the mechanics that are involved there. So if you're curious about anything around the changes we just made, just let's put those questions in the question and answer section, and I will slowly prepare for the next steps in the meantime. And well, All right. So this is the model of the list that we are going to use in our history view. So we are not going to implement the interface once again. It's exactly the same rule for it, with that difference that there is no singleton. It will be a normal model that has to be instantiated in the QML, and our single element will follow this struct. So we'll have a coffee type, strength, capacity, temperature, and the date when it was brewed. And of course, our model is inheriting from the list model, and in template argument, it's taking the type of our single element. We are overriding the data function, data method, to provide a single item for the given index. We have also override that count method to provide the size of the whole container. We have additional add value method that will be useful for adding new data for our list. And as you can see, of course, there is a model reset, which will tell Qt for MCUs that data underneath has changed, and you have to redraw the QML component that is using that model. And of course, some std vector that will hold our informations about the history. All right. So right now, let's go to coffeemaker.qml. So to download our root file, and somewhere near the history view. So let's find history. Here it is. Okay. Let's instantiate the coffee model. We cannot access that globally, so we have to reference that by ID. Our coffee model instance will look like this, and let's give it some ID. Model. Perfect. And to history, we can add right now our model, which is coffee model. And the history, let's review the file, is taking the model as a property alias, which just is just passing that model to the history list. And the history list, let's find it, is another QML component which has the coffee model property, so the same type as our class exposed from the C++, and that model then comes to list view model, which use that in delegate to build each type of each element of our list from the history view. And as you can see, here is, for example, the reference to the model coffee type to render some text in the text element for the single history entry. Well, so this is how it works briefly. Okay. And just to prove you, I will show you that it's still not working. And let's quickly review that. Espresso start. Let's brew that. Okay, we have. And the history is empty. Right. So let's fix that. Let's get back to coffeemaker.qml. And what we would like to do. So we would like to know when the coffee has finished its brewing. And then we would like to reference our coffee model and add the new item there. So we will need some, for sure, helper functions to convert some indexes to names and strings. So we have to import helpers. Some version not important, but needed. Okay. And let's try to find the, yeah, this will be a great thing. On brewing finished, right. So our brewing progress is exposing a signal that brewing has finished. And we are going to add our logic there. Coffee model has the function for adding new items, so add value. Okay, I will just remind you how it looks. So this is exactly this this function add value. It has 1, 2, 3, 4, 5 arguments that we are going to fill right now. Let's go with adding those. So we will need coffee name, but we will retrieve that from coffee index. So I will go through helper functions and get coffee name. And let's provide the coffee index there. Coffee params, coffee index. Okay, so that's the index of the coffee that has been just brewed. Do not forget the comma there. Okay. The next one was the strength, coffee params strength slider value. The next one was coffee params, not model. Okay, coffee params, and that's capacity slider value and temperature. Params. Oh well, maybe not. Right now, we would like to add the timestamp for our coffee. So for doing that, we have our additional model. I'm not sure if you remember. This is the timestamp, which comes from previously prepared files from the training materials. And this provides a way to get the current date and time in the string. And we are going to use those. So timestamp current date. And let's concatenate some empty space. That's also a pretty useful thing that you can simply concatenate the strings directly from QML. Timestamp current time. So then we'll have some exact date, and time is less important, so we will go on the last place. All right. And this will go to our model as a single string, split it with that empty string. Of course, there is a moment to test out our changes. So let's be a normal user right now. So let's start. Let's pick espresso. I like a little strong coffee. Espresso has to be small, and temperature, let it be medium. Let's brew that. It's done. So let's get back and let's see, do we have the history? Right, we have. So that's how it works. And let's try to verify that one. So there is a Cafe Mocha as well in the history view. Okay, last cappuccino. I'm not sure how to pronounce that one. And okay. And the cappuccino is also there. Well, maybe let's change some parameters as all of those were exactly the same. So mild, big, and high temperature. And the parameters are different. Mild, it's a big size, and high temperature. List is, of course, moving. And last thing to do is to verify if our product works on the board. So let's compile the things for our NXP 1050. And for a while, I will still leave the compilation screen and all other things, as the flashing process will take a while. Okay. Flashing process is still started. Okay, it's started right now. All right, I will be slowly switching to the secondary camera. This is a still old view. It's still flashing. The application is right now quite a big one, so it's taking a bit more time than previously. All right, we have it. So let's start brewing something. And for example, let's pick something that we didn't before, a ristretto. It will be a very strong thing. And let's start. The brewing is done. Let's get back. Let's brew another coffee for friend. All right, so we have a coffee and we would like to see what's in the history. And in the history, we have our strong coffees. We can also verify that other languages are working fine. And let it be short brewing this time. And that works as well. And let's get back. Let's verify the history. And as you can see, even parameters that are there in the history are also translated. So everything works across the whole application. And that's pretty much it. Let's click that. It's hard to use the upside down. Right, so right now it's in German language. So we have finished our application. And right now there is a moment to sum up the things and just show you a few things more about the upcoming releases. So this is about integrating the C++, and you can use that way of integrating things to connect your other parts of your application. For example, the other hardware components or drivers that you are going to use. And in my opinion, it's a quite convenient way of doing that. It works pretty well. So you shouldn't have any problems with introducing your own logic around those mechanisms that are provided in Qt for MCUs. And let's see what's on our roadmap. So besides those things that we were talking during this whole 2 days, there are additional things. This is not all that Qt for MCUs comes with, of course. To save some memory for texts, to not compile all of those into the binary, you can use monotype Spark font engine, which will generate the glyphs in the runtime for you. It's a bit slower solution for rendering texts, but it could save you way much more memory than using the static font engine that I presented to you before. Qt for MCUs also supports 2.5D transformations. So the carousel, for example, is probably the flagship example of using the 2.5D transformations, which of course can be used for more advanced things. It depends just on your application design. You can make use of off-screen rendering. So Qt for MCUs can also be a software that could render some images that are not going to be shown on the screen, at least not in your device. It can be generated there and sent to other devices across your ecosystem to make use of that. In general, the whole Qt for MCUs may have a support for hardware layers. Some of you maybe know that feature from the old Amigas and all gaming consoles, that there are some hardware layers that can save you memory by reorganizing some parts of your application to different layers that can consume less memory than the whole frame buffer for the whole screen. You can also use that to improve the performance of your boards. as the hardware layers typically comes with hardware blending support between the layers. So our boards generally supports that. Some of those have the layer support, some not, but it's still compatible feature with those. There is also a Qt Quick Ultralite Shapes API for vector graphics that can handle the SVGs or the QML API for that. For example, one of the NXP boards that has a hardware support for that is NXP RT1170, which is the board targeted for the automotive industries. You can also, well, yeah, we partially covered that, build Ultralite as a static library that can help you organize your project and connect with other teams that are working on different components of your whole application. And if you are curious what is going to be added in the upcoming releases, so of course there will be improved tooling support. So Design Studio integration will be much better than right now. Qt Creator will get rid of those warnings and error messages that you were pointing out during this training. Trust me or not, this is a really huge piece of work to integrate all of the edge cases and the features of Qt for MCUs to the tools that were existing before that product. But we are working hardly to provide better support for tooling. We are still adding new reference boards, so you will have the bigger amount of the out-of-the-box supported devices from which you can choose and from which you can analyze which one is better for your needs. We are still adding new compilers and tool chains. So as I said, currently we have ARMGCC, we have the, I will never pronounce it properly, IRR compiler, and there is also Green Hills compiler support, and there are a few more that are going to be added in the future. We are still improving the platform abstractions, so this is directly connected to one of the last questions about integrating the separate LCD. So if you are going to modify your modify Qt for MCUs for your needs, as we probably all know, the MCU devices are more likely to be customized in the final products. So we are working hard to improve the platform abstraction to minimize the amount of the work and simplify the work with adapting Qt for MCUs for your needs. And in the 1.9 release, so in upcoming weeks, we are going to release the support for Linux host machines. So not only Windows 10 will be supported, we will support Linux as well, which I'm using personally to even develop the product, and it works perfectly. So this could be interesting for you to test that out. And in the future, of course, we are looking into providing the macOS support, but the date for it is not yet known. And of course, we are still working on improving documentation, and we're really working hard to make you happy with the things that are still going to be added to upcoming releases. And that's it. If it goes about this Qt for MCUs getting started training. Thank you very much for being active during this training. You're the group that was probably the most active during the training's history. So thank you very much for that. Thank you for your feedback that were appearing in the chat and in the question and answer sections during the training. This helped me out to provide you better trainings and to focus more on the things that are important for you. So the last thing I would like to ask you about is to provide me some feedback, some thoughts about this training session to my email directly. If you have any questions about Qt for MCUs or some particular parts of it, please feel free to ask me directly on the email address. I will for sure be happy to answer all of your questions even after the training. So, well, thank you very much. I will still wait a bit. Maybe some of you still have some questions. You can still ask those using the Q&A section. or even using the chat. That's any difference for me. So, well, for me, that's all. All right, so I guess everything is clear. So, okay, there is a question. How do the timer, oh, well, okay. How do the timer ticks work? Well, you're probably saying about this one, or in general, the timers. You're just tell me if you are asking about the timer we have for our purposes for the demo, or in general for the timers that are in the Qt for MCUs. Oh, well, so, okay, I understand the question right now. So the way how it works is, well, let me put that way. So each platform has a platform interface to implement. And of course, this depends on the platform, how to implement the time concept. Yeah, well, so Qt will ask you, so Qt engine will ask the platform through the platform interface to provide the timestamp. And you have to provide the timestamp from the platform, and depends on how platform can do that. You are implementing that API in the platform interface, and based on that timestamp that is received from the platform, the Qt for MCUs engine decide and counts how much time has elapsed, and if the time for ticking a timer is right now based on the timestamps that are coming from the platform, then the timer is called simply. So this is how timers work. Well, exactly in the same way. So let me put that on the screen. Well, if you will look closely, I will switch to timer, not timestamp timer, brute timer, and then let's switch there. So if you will look closely, this timer is a Qt timer. So this is a purely Qt for MCUs type, which use the same logic to handle the ticks. Well, let me show that here. So you're setting the interval there in the brute timer, which is the Qt timer, Qt type, and this timer is strictly tied together with the whole rendering loop, and it follows exactly the same way. It's registered in Qt runtime engine, and if runtime engine based on the timestamp that is receiving from the platform decide that this interval has elapsed since the last time, and if the timer is started, then it will just hit the on timeout event on this particular timer. All timers will rely on the same concept there. Okay, great. Well, are there any more questions? I saw that there was one. Thank you. So thank you very much as well. All right, so I will just simply thank you once more. If you have any more questions, feel free to ask me directly on the email. I will answer all of the additional questions that will be there still even after this training. Thank you very much again, and goodbye. Thank you very much. We'll look forward for your email. Thanks. Bye.